Chapter 5 has to do with identities, all about identities, and this is crucial in being able to manipulate information into a workable form in calculus. It is stronger of what we have done. It is more pertinent in understanding and how we perceive the importance of learning the trig identities. You'll need to copy these down if you don't have them already in this small cheat sheet that I have given you that you can print out. But it's best you get a handle on what we have learned and how it will apply to calculus. So here we start with the reciprocals. The reciprocals can be used to convert to sine, cosine, and tangent rather than consider the reciprocal function. The quotient identities, these are new. I haven't mentioned these at all. And what we have is this concept. So we've learned that our ratios are cosine of S and sine of S. That replaces X and Y. Well, we know that the tangent of theta is Y over X. Well, Y is sine of that angle over cosine of that angle. So now we can see the easy conversion. And of course, the cotangent is reciprocal value. So we're doing all in reference to functions. All right. Now this one is very critical. We understood that in a right triangle, that we had a squared plus b squared equals c squared, right? And in our positionary aspect, we can then say that cosine squared theta plus sine squared theta equals, and in this case, 1. Because in the unit circle, all ratios squared and added equal 1. All right, so that is very, very important. Very. So let's look at how they got the other two. All right, so they call them Pythagorean identities. So if I have sine squared theta, they always put sine first, and I'm not sure why. I've never really had time to consider that. Supposing I divide by cosine. Cosine squared, to be exact. If I do this, well, this is what? Tan squared theta. This is 1 equals, and the reciprocal of sine squared 1 over cosine squared is secant squared theta. And by just dividing through, well, if we take the same sine squared theta plus cosine squared theta equals 1, and I divide this time by sine squared theta, Then I'm going to get 1 for this plus cotangent squared theta equal to the reciprocal of sine squared theta is going to be cosecant squared theta. Now these bottom ones, you don't have to memorize, you just have to know to divide completely through one or the other to get your desired identity. Then we have our even odds. Now we did this in chapter 4 so that we know that the sine is odd, the cosine is even, the tangent is odd, the cosecant is odd, the secant is even, and the cotangent is odd. All right, because of the y. So let's begin with utilizing our identities. All right, so what can we say about tan x? Well, we know tan x is going to be, if I can get my pen to work, sine come on. Well, isn't that funny? I think my battery's probably dead. Okay, let me start right there.